Today we're going to be looking at what are called the classic five, or five chemical reactions. Many of the reactions in chemistry will fit into one of these five, and we're going to go over three of them today. First one's going to be called a combination reaction, which you'll also have a lab on. The second one's going to be a decomposition reaction, which there'll also be a lab on. And there'll also be a single replacement, which we'll do in this lecture as a demonstration. PowerSchool indicates that you're not going to be doing the actual lab. So let's go ahead and get to these three. So we're going to write the names, we're going to write the definition, and then I'm going to give you an example of that type of reaction. So the first is going to be called a combination reaction. So a combination reaction. Look at the root word of combination. What's the root word of combination? Hopefully you're seeing the word combine. So with a combination reaction, this is when two substances, sometimes it could be more, but we're just going to say two substances combine into one. Two substances combine into one. Now, let me just give you some letter reference. Let's say you have chemical A, and we're going to be adding to chemical A chemical B. In a combination reaction, these two separate things, these two separate reactants are going to combine into a single product. So they're going to become connected as AB. We've seen this before, actually, and if you remember the magnesium, when I burned the magnesium a few lectures ago, we have the magnesium as one substance, and the magnesium is burning in the air. We're going to be doing some balancing here as well. So we have the magnesium burns in the oxygen, and these two things combine to produce a new material. And that new material is magnesium oxide, MgO. So here was the silvery metal magnesium burning in the oxygen, and it produced this white ash. Let's see if we can balance this. There's one magnesium here, there's one magnesium here. There's two oxygens here, there's one over here. Remember, I can't use the subscripts to change, so I have to use the coefficients. This gives me two oxygens to match the two over here, but then it also gives me two magnesiums. So I have to come over here, and I can't balance with the subscripts, but I can with the coefficient. I'm going to put a 2 right there. The two magnesiums, the two magnesiums, the two oxygens, and the two oxygens. So that's a combination reaction, and you are going to be seeing a combination reaction with zinc and iodine combining into a new compound called zinc iodide in the lab. The second reaction is a decomposition. Decomposition reaction. Now look at the root word in decomposition. You'll notice that the root word of decomposition is decompose. It's the opposite of a combination reaction. This is when two substances combine into one. Well, what does it mean to decompose? To decompose means to fall apart. In a decomposition reaction, you have one substance. It's the reverse. Instead of combining, one substance is going to fall apart. So it falls apart into two. It could actually fall apart into more than two, but for this reaction, for simplicity's sake, we're going to have one substance falling apart into two. So imagine that you have the opposite of this. So we're going to start with this compound CD, which is already combined. These materials are fused together into one compound. This one substance is going to fall apart into the two separate ones, C plus D. The one substance falls apart into two. This is the decomposition reaction. And what you're going to be seeing in the lab, in the decomposition lab, is we're going to be starting off with hydrogen peroxide, H2O2. Let's go ahead and put this here. This one thing is going to fall apart into two other substances. And the two things that it falls apart into is going to be H2O and O2, oxygen. So let's balance this. We have two H's here, we have two H's here. We have two O's here, we have three O's over here. Now this is a tricky part because we have two different compounds with oxygen in them. So we just can't start doubling things. We can't double all these things, because if we double these, then we're going to get, we'll have 2, we'll have 6, and then we might not be able to balance other things. But we need to get an even number of oxygens. So notice how we have 2 over here, and over here we have 3. This is the oddball right here. We can make this even very easily by making this into a 2. But we're not going to double that over there because we don't need to. So now that we have 2 times 1 gives me 2, and 1 times 2 is 2. 2 plus 2 is 4. Well, 2 times what will give me 4, and that's going to be 2 over here as well. 2 times 2 hydrogen gives me 4 hydrogen. 2 times 2 gives me 4 hydrogen. So this is the balanced reaction. We've already worked on balancing, but this is just to show the decomposition. It's the opposite of a combination. Combination is when 2 substances come together to make 1. This is when 1 substance falls apart into 2. The third reaction is going to be called a single replacement reaction. Single replacement. In a single replacement reaction, one element is going to switch with another. So think of a substitution on a basketball court or a soccer field. You're going to have a replacement or a substitution. One element switches. And when you're on the field, the 2 players are going to switch. When you're on the court, the 2 players are going to switch. So one element is going to switch or switches with another. Let me show this in letter form, and then we'll get to an actual demonstration. We're going to go up the alphabet, going to start with E. Imagine we are starting off with substance E, and we have this compound Fg. So what's going to happen is, with a single replacement, you have an element. So here's my element. My element is always going to be a single thing. So here's my element right here. And what's going to happen is they're going to be switching with each other. So these 2 are going to switch places. So the E is going to come in, it's going to kick out the F. It's going to kick out the F, and it's going to create a new compound. The new compound is going to be Eg, because the F was kicked out. And so it would look like this. So here's a demonstration that I have. Here's a small beaker, and I'm going to be adding to this beaker some hydrochloric acid. You've done this in a previous lab as well, where we produced a gas. So here's my compound, hydrochloric acid, and here is my element, which is going to be some magnesium. So starting off with the magnesium, I'm going to combine this with the compound hydrochloric acid, which is HCl. Let's put in some spaces here, because we're going to need those. And let's try to see what's going to come out of this. What's going to happen is the element is going to be switching places with the H here. So the element magnesium is going to switch places with the H in the hydrochloric acid. And it's going to kick the H out, and then the H is then going to be all by itself. So what's going to form are 2 compounds, and the 2 compounds are going to be magnesium chloride, MgCl2. The Mg and Cl, when they combine, you have to have two Cls to form with this. Just like H2O, you have to have two hydrogens to combine with the oxygen. In this case, we need two chlorines to combine with the magnesium. So the magnesium comes in and kicks out the H. Then you have the H, which combines with another H to create the gas hydrogen. So those are the bubbles that you see in that reaction. Let's go ahead and balance this. We have one magnesium here, we have one magnesium here, we have one H here, we have two here. So we're going to have to balance this with a 2 in the front right here. Now I have two H's and I have two Cl's. Notice how I also have two Cl's already on the other side. So those are 3 of the 5 classic reactions.